but even if they do, it's still going to be the same type, same form. There's not that many searching questions on the exam. Most of the questions, if you've done the material, just read them and answer them. If we do, a lot of the questions do not have a numerical solution. It's just a word solution, yeah? So I get through, so now you should know, go through the concepts that you need to know as I go through the questions. You need to know this idea about parameter, about population. So about population and the sample. You need to know this idea about population and sample. So think of you like a sentence or two, and they set up a scenario, and they say, they did it to you on your previous exam. They may ask you, what is the parameter? What is the sample? Is it the 200 people that have trained code from one like that before you remember that? So you need to know that the population has parameters mu and sigma, and you need to know that the sample has parameters x bar and x. Yeah? So, but don't confuse the terms. If they're asking you a question about the sample, then you have to figure out if it's a sample or if it's a population. The first question is just asking about sample. Is the data they're giving a sample or population? You're going to figure out. It's very straightforward. Don't get sidetracked by all the alternative answers they're giving. The question is asking you if you have a sample or population. That's what you stick to. Yeah. So the answers is just you have A, B, C, D answers, and you just have to pick out the data you use a sample or population. The next one I see here is about inferential statistics. Inferential statistics. So what we're inferential statistics, just remind ourselves what it is. You need to go through this stuff and remind yourself as well. But inferential statistics is when I want to work something out for the population, like the mean of the population, that's what I want. But I do it by choosing a sample, working out the sample mean, and inferring that it's going to be a good estimate for that. Okay, so that's what inferential statistics are. So we seek to find information about the population figure, yeah? We may be doing it through the sample, but we're actually seeking a result for the population figure. That's what inferential statistics is about. I want to find out something about the population, ultimately. I may use a sample to do it, but I want to find out something about the population. You need to know the definition he gave us of data science, statistics as a data science. So look at the PowerPoint so you can get the exact definition he's got of what statistics. Is it a way of getting data from information or information from data or something like that? You need to get it the right way around. He's very pedantic. Yeah? So what is it? So it's in your PowerPoint, so you remember seeing it, yeah? If you don't, just look back, you'll see it in there. There's another question that you had before, yeah? And this question was relating to what are we studying? Are we studying accounting, marketing, management, or business analytics?
That's a real question.
Some of you guys got that wrong last time.
Oh, wow. What? Oh, I didn't
That
have
question, we gave you a scenario, and he said this, but we're just not studying business analytics now, so we're not studying. Anyway, there's another question which it just generally tells you what we're studying about.
Right.
It's asking what subject are we studying. Some people went actually went for marketing, some people went for accounting. It was a sneaky question though, because it just the way he asked it. If you try to get into the question, maybe he managed to sidetrack some people.
Is the answer business analytics?
I don't know, I can't give you answers.
What are we studying?
What were the options? Accounting.
That's like hard
Look at the PowerPoint, it tells you. now we're moving on to sampling, and it's asking about when you pick a sample, what sort of bias or causes to make your sample non-random, and it's anything to do with bias makes it non-random. So. Yeah.
So we use a written cheat sheet, right?
Right.
And then is it just one side or?
As much as you want.
Okay.
And you said as much as we want.
If you're sitting it here, it's not, you can do whatever you want. Like if you're taking it anywhere else, but anyone's taking it anywhere else, I think there's one in this class, but if you are, you have to stick to like one page. Back and front, one piece of paper, back and front. Then there's another question here about parameters, which are population parameters and which is sampling parameters. So it's back to this. So these guys are population parameters, these guys are sampling parameters in here, so you need to know that. So no calculations yet. Now, let me ask you, remember the interquartile range? That was the thing where we did something like, we had a box like this between Q2 and Q3, and then we did something like this and something like this. We said anything out here was an outlier, yeah? So it was easy to see what the outliers are when you look at a box plot, yeah? What percentage of observations were in here? 50%. Well done. So make sure you know that stuff. You have to know about skewness. You also, right, so but the next question, you need to know about the empirical rule. Where's the empirical rule, remember? Yeah, so for a normal distribution, you have a normal distribution, yeah? And you get, within plus or minus one standard deviation of the mean, you get 68% of the observations, plus or minus 2, you get 95, plus or minus 3, he said approximately 100. You need to know that rule. And for you to be able to apply that rule, you must have a normal distribution, yeah? Don't have a normal distribution, you can't apply that rule. What are the parameters of a normal distribution? Can someone tell me? Yeah? Parameters just mean side measures. So if I say you've got a normal distribution, it's bell-shaped, it's symmetrical, the area under the curve is 1. But you need some additional side measures called the parameters of the mean set. The mean tells you where it sits in space. As the mean increases, it shifts that way. As the mean decreases, it comes back this way. As the standard deviation increases, it flattens out. So, but the parameters of this value are similar. Change the wording of some of these questions. Or the wording is. This is another the question I'm looking at you've had come up before. Some of you had it come up before. So I'll just paraphrase the question for you. If you've got somebody, you've got a bunch of students that are planning to go to Harvard, and only the students with the highest GPAs are going to get in. And if I tell you GPAs are normally distributed, so I'll tell you that the GPAs are normally distributed. Only the students with the highest GPAs, this GPA is over here, so only the students with the highest GPAs are going to get in over here, yeah? Is that going to have a large Z value or a small Z value? This is 0 Z value, this is minus 1, this is minus 2, minus 3. Okay. So you're going to be positive and larger, yeah? There's something in the notes as well that tells you about skewness and how the median changes with respect to the mean. How does it change? Who remembers that? Well, if a distribution is positively skewed, it's being stretched out to the right, which moves more, the median or the mean? Oh, we've got split. So look, it's right in your notes. See your notes, guys. Right at the end of that long active notes, it actually says, this is the rule. How would you detect outliers? Would you look, what do you think? What do you think is a good way to see outliers? Would it be, that's a good word over there that I wrote up over there. If I draw a box plot, that'd be a good way to see if there's any outliers, yeah, lying outside those ranges. You know the empirical rules, that 68, 95 and whatever, that only works when you have a normal distribution. If you don't have a normal distribution, how can you work out the similar thing if you don't have a normal distribution? Some Russian guy came up with another method. Chebyshev, yeah, so you have to know what Chebyshev is used for. Yeah? So basically finding, like here we found the percentage of observations here between -1 and +68%. On Chebyshev it's going to be a slightly different percentage, but it's going to tell you the percentage of observations between 2 points. So now you're focusing on where you need to study and what you need to look up. They've got several questions, at least 2 questions on the exam, which are asking you what do you type into Excel to work this thing out? And so, if I want to find out on the normal distribution something to the right, I have to use 1 minus norms dot this. If it's something to the left, it's just going to be norms dot this, yeah. So you have to know that, because Eric can actually ask you, not to do it in Excel, but say which of these would you choose to do this calculation? Yeah? When do we use Z and when do we use T? We use Z when we know the population standard deviation. We use T when we know the sample standard deviation. And for confidence intervals, we need to know the formula for confidence intervals, and we need to how to work out each individual part for the confidence intervals. Yeah. So we need to be able to work out the critical values. With confidence intervals, it's always alpha over 2, isn't it?
Sorry?
In confidence intervals, you always use alpha over 2. So when you're trying to work out the critical value, it's going to be alpha over 2. So, for example, if I've got if I know the population standard deviation, let's do this. I know the population standard deviation, yeah, and I want to work out confidence interval. If I know the population standard deviation, I should be using Z. And if, say for example, alpha is 10%, what will my critical values be? 10%, 5% on each side, 1.645. You should be able to calculate that. If alpha was, if the confidence interval was not 90% but was 95%, then my critical values would be, do I remember the results? 1.96, yeah. So, but you should be able to work that out, even if you don't remember, just work it out, yeah. point estimate is the same as x bar. The critical value, the critical value is just this thing. Are these cutoff points? If it's Z, if I know what the area is, like, you figure out how you want to do it on the exam, if it's a 2-cell test, if it's a 1-cell test, whatever it is. So if I tell you this is alpha equals say 5%, then this value in here, if I know the population standard deviation, so I can assume it's Z, this is going to be norm dot S, if it's standard normal, norm dot S dot inverse of 0.05. Okay, and that should give you negative 1.645. Yeah. When we do hypotheses testing, remember I told you it's fundamentally flawed. There's an error we can make in hypotheses testing. In fact, if you come up with the correct null hypothesis, we know there's an alpha % chance of rejecting the null hypothesis that is true. Remember that? So we know there's going to be an alpha % chance, whether alpha is equal to this 5% attempt to whatever, there's always that alpha % chance that you reject it, it was in fact true. So there's like an alpha % chance you make a mistake. What was that mistake called? Yeah. Type 2 was something else completely. It was something else. Yeah. It's just type 1. The next question here is just asking about the critical value approach. It says if the critical value is greater than your test statistic, or whatever, it sets up a scenario, and you have to say, in that case, you would reject H0 or not reject H0. Yeah? Okay, so you have the critical value approach, you're just comparing your test statistic to your critical value. Okay. So you have to read up on that. When do we use Z? I already said it before, but when do we use Z? When we know the population standard deviation. If we know the population standard deviation, do we also know the population variance? The answer is yes, we do, because it's just the standard deviation squared is the variance. So sometimes they may be talking about if you know the population standard deviation or the population variance. As soon as you know it's the same thing. I know the population standard deviation or variance. So then I would use C. If I don't know those two things, I'll use C. Then you've just got some kind of random question about, what cannot be a null hypothesis. Gives you a list of hypotheses. So which of these cannot be a null? Well, to be a null hypothesis, you have to have an equals in it. Equals, greater than or equals, less than or equals. They're all null hypotheses. Alternatives are not equals, greater than, or less than. You need to know that, yeah? If you're not sure, put it down on the cheat sheet and bring it in with you. So that's the first 19 questions, and there's no numbers in sight here. Next, what I've seen here, you may not get it, but you should get something similar. The next batch of 7 questions I see are on two-sample hypotheses testing. Oh, sorry. So the next 7 questions I see are on linear regression, which we were doing just recently, last thing we did. Right. So the first of those questions asks you, how do you figure out and y are related. And I mean, that's an open question, but it gives you a set of answers and they're all in the same ballpark. Basically, the way you find it out is you do that test to see if the slope is equal to 0 or not equal to 0. The slope, do you remember that when we did that? You want to test to see if the slope is equal to 0 or if the slope does not equal 0. That's the test that you run. Okay. So you got a question on which is the correct combination of hypotheses you would want. So it's going to give you, that's the correct one, so give you some wrong ones as well. It actually asks you for the test statistic as well, which it gives you, this question does give you a few numbers, but it actually asks you to work out the test statistic. Who remembers how you would work out the test statistic, this sort of question? Yeah, but they're not giving you the raw data. So this one, even though in the notes it said they weren't going to do this, they are B1 minus beta1 divided by the standard error. Do you remember that? That's in your notes. That's the last set of notes we did. B1 will just be your intercept. Sorry, B1 is your slope from your sample. They give you that. This guy is going to be equal to 0. Let's look at the notes, the example we did in the notes. And the standard error they give you. So they give you this, and they give you this, and this guy is 0. So you just divide out those numbers and you get. But check it out. It's just like the question, like the worked example that they got in the last PowerPoint. Then they ask you to work out the p-value, just as they did in that question in the last set of slides that we went through. So the p-value we have to remember, well in this case our test statistic, say for example it's going to be positive. The test statistic is positive. How do we work out p-value? If our test statistic is how do I work out the p-value? Assuming we have a whatever distribution we have. How do I work it out if it's to the right? If the test statistic is to the right, if it's a positive test statistic, do we have to use a 1 minus? Because if I just try and work it out normally, I'm actually just going to work out the left, so I have to do 1 minus. And then if the question, just look at it, just go through it. It's very similar to what's in the PowerPoint in the last set of notes. And the other thing is, if it happens to be a 2-tile test, which in this case is a 2-tile test, yeah, then you have to multiply everything up by 2. So check it out, yeah. It's probably T, isn't it? Remember? So I want you to look into this, yeah? I don't need to tell you just write it down, you don't just turn up to the exam without doing any work. Yeah? The next question is, would you reject or not reject? You know the p-value, p-value of alpha. And then the next thing it does, it's actually giving you the intercept and the slope. And it's asking you to work out a particular value of y, a value of y for a particular value of x. So basically, remember the one we did in class today? It was something like we found out that the parcels equals b0 plus b1, and x1 was the number of adds that you put out. Remember that? So they're going to give you b0, they're going to give you b1, and they're going to give you a certain number of adds. They're going to ask you to find out the parcels. Well, that's what we did. This is what the next question I see here is about. So it's just about working at predicting a particular value. It's not going to be parcels, it's something else. But it's the same idea. what is the interpretation of R squared? So we need to know, look up the definition of R squared. And you have to erase, if it says y and x in your definition, you have to be able to replace y and x with dependent and independent variable, and not just generically dependent variable, whatever the dependent variable is in the question. So in this case, the dependent variable is car sales. So I have to talk about the amount of variation in car sales brought about by variation in the number of ads. So you have to be able to do something like that. Okay. So it's not just enough to know the generic version of it. You have to take out the x and the y and put in the x and the y that you have for that question. And the final one on this batch of questions and there's another question here which is asking you about the slope. And in the question we did on car sales, what we actually had in terms of slope, this equals, car sales equals 10 plus 5 times the number of ads. And then we said, what does that mean? What does that 5 mean? Well, it means as I put out one more ad, I expect to sell 5 more cars. Yeah? Is that right? That's what the slope is, so you have to know that as well. So I guess if you just go through that last set of PowerPoints, the stuff that we focused on, and that's going to get that whole of that out for you. So it's halfway now, we're halfway through. But most of the questions, you can see they have fast answers to them. The next 3 questions that I have, you may not have the next 3 questions, but it's giving you a flavour for the sort of thing that they're going to be asking you, is on 2, sample, hypothesis testing. They give you the sample size, they have 2 samples, they give you the sample sizes, they give you the means of the samples and the standard deviations. They give you the test statistic and the p-value and the degrees of freedom for this question as well. So as I'm going through, I'm seeing things, I actually go back and add some things in. I did that last time, they changed about the exam, so. The non-alternative hypothesis for matched pairs. Sorry, not for matched pairs, for 2 sample. And they give you 2 alternatives. And as before, one of the alternatives is fundamentally wrong. It just doesn't exist. We can't have that. So it's got to be the other one. Just to make sure that we all know what I'm going about here, is that the combinations we have are H0, whatever it happens to be. I just whether it's 1 tail, 2 tail, you get an equals, and with the alternative, not equals. That's one pairing. Then you get another pairing, which is greater than equals, with the alternative less than. That's the second pairing. And then you get a third pairing, which is going to be u is less than or equal, with the alternative u is great. That's the third pairing, yeah? They're the only pairings you can have. So if somebody says mu H0, mu was not equal, that's wrong. That always has to be an HA. This always has to be an HA. This always has to be an HA. Okay? And if I switch up, you can't have it. Or even if I take this H0 with this HA, it doesn't go. So these are the only pairings you can have. So if you see anything that's not one of these pairings on on a matched pairs question or a two sample question, I'm not talking about ANOVA, then if you see any pairing other than those, then it's wrong. And because I'm only giving you two options, A and a B, then you can see, you should be able to pick up relatively easily that one of them is wrong. Yeah? I'm not being funny, I think that I could go, or you guys could go through this exam, not read the question, and a lot of the questions you can answer right because you can see the alternatives are just wrong. Just not read the question and say that, then you can't, it's only A or B, and say for example B is wrong, it's got to be A, without even reading the question. So I mean, he could have been really mean on this final exam, but apart from a couple of questions that are a bit iffy, the rest of the exam, even those they're not bad, the exam's fairly straightforward, I've got to say. I've never seen a final that's so straightforward. So if you do the work, hopefully it's going to be your biggest score. So anyway, so 3 questions on 2 samples. The first one is getting the hypotheses right. Sticking to this in here. The next one, should you reject or not reject at alpha equals 5%? It gives you the p-value, it gives you alpha. If alpha is greater than p-value, reject, otherwise you don't. And then surprisingly, the next question, if you get this version, it asks you to it just changes alpha from 5% to 10% and asks you to run the test again. So that's, I feel that's like kind of giving stuff away. So he's trying to give some points away there. So it's just asking you to do the same things twice, like. Okay, that was 3. 1, 2, all right. Third one. The third in that batch is. Oh, so we already did that. Reject or not reject at 10%. Then we've got another 4 questions now. And they are on matched pairs. They give you the test statistic, and they give you the p-value. It does say paired data. Again, they want you to come up with the correct null and alternative hypothesis, A or B answer. One of them is fundamentally wrong. So you don't have to struggle, keep on going back to the question, trying to figure out which way should I do that. Yeah, you just be smart about it. So, well, that was obviously wrong, so it's got to be that one.